Hi guys, today we're going to look at an example of graphing a rational function. If we recall, a rational function is a function where the numerator and the denominator are polynomials. So let's do a fairly complicated example. Looks like we're going to try to graph f of x equals x minus 1 over x squared minus 2x minus 8. So we're basically just going to go along the step-by-step process of graphing a rational function. We're going to basically just plot a bunch of points, and we're going to make sure that we know if there are any asymptotes that will help us graph our function. So our first step is to see if there is any symmetry, and the books often ask for this. It's no big deal if you skip this step. You can still get a good idea of your graph just by plotting the points, but to check to see if you have any symmetry, you just see what f of negative x is equal to. So wherever there's an x in your function, just plug in negative x and simplify. And if what you get out of it is equal to f of x, or it's equal to the negative of f of x, which would just be a minus sign in front of our original rational expression there, then there would be symmetry around the y-axis or the origin respectively. But in this case, this is not equal to either of those two, so we don't have symmetry on this graph. So step 2, we're going to find the x and the y-intercepts, if there are any. This is just like finding the x and y-intercepts of any other graph. To find the y-intercept, we set x equal to 0 because we know that any point on the y-axis has an x-coordinate of 0. So we do that, we plug in 0 for x, simplify, and it looks like we get 1/8 as y. So our y-intercept is going to be 0, 1/8. And to find the x-intercept, we're going to set y equal to 0. In this case, when we have a fraction equals 0, that just means if whatever the numerator, whatever x in the numerator makes the numerator 0, that's what we want. So we can clearly see that if x is 1, we get 0 in the numerator. 1 does not give us 0 in the denominator, so we're safe there. So the x-intercept is the point 1, 0. So I'm going to begin on my graph just by plotting these 2 points, and that'll give us a good start. So I'm just going to plot my x and y-intercept. Here's my y-intercept, 0, 1/8, and here's my x-intercept, 1, 0. As we can tell, this is just 2 points. This doesn't really give us any idea of what our rational function graph is going to look like, but it's always a good start. So the next step is going to be finding our asymptotes. So vertical asymptotes occur when our denominator is equal to 0. Those are going to be the points that the graph is undefined for those values of x. It looks like we've got a couple here since we've got a second degree trinomial. We just set that equal to 0. Luckily, this is one that you can factor. Often the ones that you're asked to do will be the same. X squared minus 2x minus 8 factors to x minus 4 times x plus 2, and when that's equal to 0, one of these two things has to equal 0, so that gives us two values of x equals 4 and x equals negative 2, that make the denominator 0. So these two are actually going to be our graphs of our asymptotes as lines. So the vertical line x equals 4 and the vertical line x equals negative 2 are both going to be asymptotes. So the horizontal asymptote, we just have to go to the rules for that. It just says since the degree of the numerator is less than the degree of the denominator, we're talking about the polynomial in the numerator and the polynomial in the denominator. The degree of our numerator was 1 and the degree of our denominator was 2. That automatically means the horizontal asymptote is the x-axis or the line y equals 0. So let's go ahead and draw in our asymptotes in our graph, and that will get us to the next step. So I'm going to go ahead and graph my asymptotes now. I like to graph them in blue dotted to make sure that they are apart from everything else. It's always a good idea to draw asymptotes in dotted lines because Dotted always means that it's not part of the graph, so our asymptotes are just kind of a guide as to what our curve looks like. It's not part of the graph. So here is the x equals -2 asymptote, here is the x equals 4 asymptote, and here is the y equals 0, or the x-axis asymptote. So basically we've divided our graph into 6 sections, so we know that we're going to have curves that are inside of these sections. We just don't know exactly what's going on. In this one, it looks like the curve will cross at this point 1, 0. We just have to see what the behavior is going to look like on either side. So the next step is just going to be plotting points. So let's do that. So a good next step is to plot points that are between the asymptotes and the x and y intercepts, and that'll give you more of an idea of what the curve looks like. So I chose -1, 2, and 3 for x because those are between our two asymptotes and they are to the left and to the right of our x-intercept. So let's go ahead and plot these points on the graph. It would be -1, 2/5, 2, -1/8, and 3, -2/5. So I'm going to plot those points. Here's -1, 2/5. Here is 2, -1/8, and here is 3, -2/5. So we're kind of starting to see what's going on here. We've got a curve that crosses the x-axis at 1. My expectation is that this curve will drop down steeply here, and this one will rise steeply as it gets closer to the asymptotes. But we still need to see what's going on the left and the right of our asymptotes, and we don't know whether the curve shows up here, or above or below the x-axis over here. So let's go ahead and plot some more points. I went ahead and picked some more points, -3 and -4, which would be to the left of the x equals -2 asymptote, and then 5 and 6, which are going to be to the right of the x equals 4 asymptote. And I went ahead and did the calculations myself. I didn't want to show all of that again because I think we get the idea. But it looks like these points are pretty close to a half, and as f increases, it looks like f of x decreases here. As f decreases, it looks like f of x increases, getting closer and closer to 0. So let's go ahead and plot these points and see what they look like. So here are 2 points to the left of our x equals -2 asymptote, and here are 2 points to the right of our x equals 4 asymptote. So we're starting to get a really good idea now of what's going on. We're expecting there to be a curve here that approaches the y equals 0 asymptote as the x values decrease in the negative direction, and the curve should slope down further in the negative direction as x approaches -2 from the right. In between the two, we've got a curve that should increase steeply as x approaches -2 from the right, and it should decrease steeply as x approaches 4 from the left. And then finally, our last section of the curve, or last branch, is over here. It will decrease towards 0 as x increases in the positive direction, and it will increase sharply as x approaches 4 from the positive direction. Let's plot a few more points that are right around our asymptotes just to make sure. So I chose 1/10 away from each asymptote, and we can see that the numbers do grow quickly. The other points that we all picked were always between 0 and 1, but as we get closer to the asymptotes, these values do increase and decrease sharply. So let's plot these 4 points, and maybe that will give us our last bit of information that we need. So here are 4 points that are near our asymptotes. Here are 2 points near our x equals -2 asymptote, and here are our 2 points near our x equals 4 asymptote. So just like we expected, this is going to decrease sharply. Here we're going to see a branch that increases sharply up in this direction, crosses the x-axis at 1, 0, and then gradually curves down here and then decreases sharply as x approaches 4 from the left side, and then the last branch is up here, increasing sharply as x approaches 4 from the left and leveling off to 0. So let's go ahead and plot the actual curve and see if we had a good idea. Yep, looks good. We've got 3 branches just like we expected, so the more points you plot, the more of an idea of what your curve looks like. Make sure to plot points between the asymptotes, to the left and to the right of the asymptotes and near the asymptotes. That will really give you a good idea of what's going on. Alright, that's all for today.